Hi guys, and welcome to the first example of synthetic substitution. This example that we're going to look at already has all of the terms that we need. So when we are given a polynomial and we're going to use synthetic substitution, what we want to do is we want to make sure that we're going to look at the highest power of the variable and make sure that every power below it is there, okay? So here the biggest exponent is this x cubed. So we have 3, a 2, and then there's really an invisible 1 here, right? X to the first power is just x. And then there's an invisible, completely, x to the 0 power, because that would just be 1. So we have 3, 2, 1, 0, and we're good to go. We didn't skip any numbers, and so we don't have to rewrite this polynomial in any way. All right, so let's jump straight into actually evaluating this. So first thing that we're going to do is we are going to draw ourselves a little noodle wumpus. Now, noodle wumpus is a very, very precise mathematical term, clearly. It's not really, but we need something to call this, and noodle wumpus is as good as anything else, and maybe that'll help you remember it. Okay, so here's our lovely little noodle wumpus, and what we're going to do is we're going to take the number they give us for x, so in this case x is 7, and we are going to put it outside of the noodle wumpus right here, because what we're going to end up doing is we're going to end up using this 7 every time we do a calculation in synthetic substitution. Next thing that we have to do is we have to take the coefficients from the polynomial and put them across the top here inside of the noodle wumpus. Okay, so let's go ahead and do that. So we have a positive 2, a negative 5, a positive 4, and a negative 1. And what we're going to do here is we're just taking the coefficients. We're not going to worry about the x's or the exponents here at all, just the coefficients. Okay, the first step, and this is really important because this is the step that everybody forgets or kind of does something different here. The first step is you just bring down the first coefficient is just going to go on the bottom of the noodle wumpus right here to start out with. Okay, so we're going to have 2 is going to go right there. Now every other step that we do is going to be exactly the same. So we're going to do 7 times 2, that gives us 14, so 14 goes inside the noodle wumpus underneath the negative 5. Okay, so we just multiplied 7 times 2 to get 14, and now we're going to add negative 5 plus 14 to give us 9. All right, now we're going to do the same step. We're going to do 7 times 9 to give us 63. Let's redo that. Give us 63, and 4 plus 63 is 67. So now we do 7 times 67, which is 469. And one more time, we add negative 1 plus 469, which is 468. And this right here is our answer. So if we had done the direct substitution and just plugged this 7 in for all of those x's, when we finally evaluated it and simplified everything, we would end up with 468. This way might look a little more complicated at first, but once you kind of get the hang of things, this way is actually much, much quicker. So I know synthetic substitution looks a little bit daunting, but trust me, you want to kind of become friends with this because it's going to be a lot easier in the end for you to use. So that's it. There you go, synthetic substitution.